All right, vertex form of the equation. So, the vertex form of the equation looks like this. The g of x equals a times the absolute value of x minus h plus k, where a is not allowed to equal 0. This is in vertex form. And what we call our vertex is the h and the k. Now, you've got to be very careful with this, okay? And our axis of symmetry is really going to go over our x values. Our line, where everything's going to be exactly the same, is going to go over the x values. So we're going to look at what happens when I'm just doing a translation like the first equation versus the second equation. And the one thing I want you to think about is this second equation in vertex form. Yes or no? Yes. Is the first one in vertex form?
Yes.
Okay. Why is this not the second equation? Shaylin?
Because the 2, which I'm guessing
Which is right next to the x. It's not the a, okay? The 2, which is right next to the x, is different. Remember, vertex form only works where your coefficient of x is a 1. Okay? So, the g function is not in vertex form. So now let's do this. In my first equation, we're going to make the table of values. You do your 2 tables. Before we even, well, let's first do the tables and then we'll do the shortcut version. When I make my first table, I'm going to plot it all out. I'm going to plot the points. First, I'm going to just make the table. Pick some negatives, some positives. I'm going to do that for the second one, too, the g of x. And then I'm going to plot them. The first one's going to be blue. The second one is red. And I'm going to draw them. Now, let's just look at. We said that the first one was in vertex form. And our vertex would be what? Remember, it's h comma k. So what is my h here, and what is my k? Now remember, the original formula was x plus, x, here's the original vertex form of the equation. X minus h plus k. Okay, so what is my h comma k in the first one? What is the vertex? What is the h? Ryan? It's a negative 2. How did you know that the h was a negative 2?
Well, the formula for shifting on the x-axis says it's x minus, in parentheses, x minus k.
Okay, x minus h. Let me go here and draw you a little diagram here. This, everything in red outside of that box is part of the original formula. So how would I get that to equal a plus 2? What do I have to input into that empty box for the h? Preston?
You put 2.
So if I put a 2, will it equal this?
No.
So what do I need to put in there?
A negative 2.
A negative 2. Remember, we said it was opposite. So my h is really a negative 2. If you see a positive in there, because the original form of the formula is minus h. And then what is my k? It's very straightforward. My k, what is my k? Ryan? Negative 3. Do you see how we get that vertex? Okay, now, in the first equation, we're seeing it's negative 2, negative 3, and that's right here. Over 2, down 3. You guys with me? The vertex of it, I'm going to go in, what color do you want me to be in? Yellow? we said our vertex is -2, -3. So I start at the origin, right? And I move -2 in the x direction, down 3. Am I at my vertex? That's the vertex of this equation. Oops, sorry, of this equation right here. -2, didn't I get that? -2, -3, because I have a -3 there. Oops. Let's see, let me go here. Okay. Now, is the other one, if I just take this and do -2, -3, is that in the same spot for the red one? So we can see we can't use the vertex formula vertex form when I have a coefficient of that x inside. Does that make sense? Thumbs up if you understand, thumbs down if you don't. Okay, let's go and let's watch a video. Now I'd like you to watch I want you to watch the Virtual Nerd video on this because I think it will clarify, okay? So let's put it on pause. You're going to watch the Virtual Nerd on...
And we can see the graph of this parent function. It looks something like this. Here we have this V shape. And we can see where these two lines intersect. That point right there is the vertex. The vertex of the parent function of absolute value functions is the origin, the point 0, 0. So now that we've seen the parent function, let's recall the general form for an absolute value function. We have f of x equals a times the absolute value of x minus h plus k. Here, a, h, and k are real numbers. Each of them controls a different transformation of the graph. And the vertex is the point h, k. So, if we could identify a, h, and k in our function, we could use those transformations to get our graph. So let's go ahead and compare our given function to the general form for an absolute value function. Again, our function is f of x equals -2 times the absolute value of x minus 3 plus 4. Now let's identify a, h, and k. In the general form, a is being multiplied by the absolute value. Here, we can see a is equal to -2. Now, with h, there's a built-in minus sign in the form. So we need to account for that in our problem. Accounting for that built-in minus sign, we find that our value for h is +3. And k is the constant being added on the end. So in our problem, k is equal to +4. Now let's take a look at these different transformations. H.
Okay, so far, are we clear on how to find the vertex? Just the vertex. Thumbs up, I understand. Thumbs down, I don't. Callie?
Sort of. Like, I understand it was its parent function.
Not the parent function, and this. We're just looking at, hold on. Shh. We're looking at just, do not wrap up. We have like 3 minutes left, okay? We are just looking at this. I'm just looking at this and this. But remember, in the formula, it's x minus h, right? So all I'm really looking at is, how do I get just what's inside the h, not that minus? So in order to make that minus become a plus, what had to go inside there?
Well, like +3.
+3. So my vertex is going to be what?
3, 4.
3, and then we just go straight with the k. Yes. Does that make sense? 3, 4.
Wait, so the formula for vertex is a, and then an absolute value x minus h plus k?
Yes, that's the vertex form of the equation. So here we go. Let's keep going. Now,
Member controls the horizontal translation. How much we shift that graph to the left or right. Since h is positive 3, that will take our graph and shift it to the right 3 units. Now let's look at k. K controls the vertical translation, shifting that graph up or down. Since k is positive 4, that will take our graph and shift it up 4 units. So, if we take our original parent function graph and shift it to the right 3 units and then up 4 units, we will get a new vertex. The vertex will be at the point h, k. So, our vertex is the point h, k, or 3, 4. And that makes sense. Taking our original vertex of 0, 0, shifting it to the right 3 units, and then up 4 units, will make the new vertex 3, 4. Now let's go ahead and look at A. A actually controls a couple of things. The sign of A determines whether our graph will open upwards or downwards.
What do you think?
Since A is negative, that means that our graph will open down. Now, let's look at the value of A. That value determines how wide or narrow our graph will be.
Wider or narrower?
If we take the absolute value, the absolute value is 2.
Wider
and 2
or
is greater
narrower?
than 1. That
Narrower.
means our new graph will be narrower than the original parent function one. And since A is negative 2, that means the slopes of the lines involved will be negative 2 and 2. Notice, in our parent function graph, the slope of this line is negative 1, and the slope of this line is positive 1. So our new slopes will be negative 2 and positive 2. Now let's go ahead and put this all together to get our graph. So let's plot the vertex that we found. Our vertex is the point 3, 4. So, plotting the point 3, 4, we get our new vertex.
Does it open up or
Now to
down?
get the rest of our graph, we
Down.
need to use the transformations that we identified. Remember, because we're working with an absolute value function, our graph will have this V shape. But because A is negative, our graph will open downward. And those lines will have slopes of negative 2 and 2. Now before we just graph those lines, let's take a closer look. Here from our vertex, our graph will need to have a V shape and open downward. So that means that this line on the left will need to have a positive slope, and the line on the right will need to have a negative slope. That means on the left we'll have a slope of positive 2, and on the right we'll have a slope of negative 2. Now let's go ahead and graph those lines. Starting from this vertex, we need to create a line that has a slope of positive 2. But usually when we find slope, we move from left to right. And here we're moving the opposite direction. So instead
How can I
of using
make
the
a
rise
positive
over 1 of 2 over 1,
2
let's
go
use negative 2 over negative 1,
direction.
since that reduces to the slope of 2. So from the
Down,
vertex,
negative
we
2,
go
negative
down
2.
2, and to the
Negative
left
2,
1.
negative 2.
Then down 2, and to the left 1. And here we have our line. If we look, we see that this does indeed have a slope of positive 2. Now, let's graph the other line. It will have a slope of negative 2. So we go down 2, and to the right 1.
Positive 1.
Down 2, and to the right
Positive
1.
1. Negative 2,
Then we
positive
connect
1.
those points and get that line. And now we have the graph of the function we were given.
Okay, let me wrap it up. Shh, let me wrap it up. So, with the vertex, looking at the equation, if I can find the vertex, what's the slope up there in the original equation? What is the slope? What letter stands for the slope? A. A stands for the slope. But it's not the sign. Disregard the sign because we're going to have both a positive and a negative. You just have to make sure you're using that slope. Once you have the vertex, you have to make sure you're using both the positive and the negative, and you're going in the correct direction of how it's supposed to be. Because it has that negative, it opens downward. Okay? Now, I've got everything on here in both videos. I've kind of videotaping the video, so I'm not sure how that's going to work out. If you want to stay and start your homework, you are welcome to.